The figure shows ray incident at an angle of pi by 3. If the plot shown in the shows the variation of r minus I versus the mu1 by mu2 is equal to k, we have to find out the various values. First of all, understand that there is a small thing missing in the diagram. This is the incident ray and initially this is the refracted ray. Okay, that is, it is making an angle 90 degree with the normal. So initially let us find out all the things. Okay, let us find out all the things. So initially when the angle of incidence is equal to pi by 3, the angle of refraction is equal to 90 degree. So r minus I, the mod will be equal to, if r is greater it will be equal to r minus I, if I is greater it will be equal to I minus r. So r minus I initially will be equal to, since it is 90 degree, it will be pi by 2 minus pi by 3, which will be equal to pi by 6. So the initial angle of r minus I, that is theta 1, the initial angle where the plot just starts, okay, where the graph just starts, it will be equal to pi by 6. So the correct answer is option number B. Okay. Let us simultaneously find out the value of k1. k1 over here is equal to mu1 divided by mu2. Since the light is originating from mu2 and it is entering the region mu1, I can say that it will be equal to sin I divided by sin r. So sin I over here will be equal to sin, it will be equal to pi by 3. Okay, sin pi by 3 is equal to root 3 divided by 2. Sin r over here is equal to pi by r over here is equal to 90 degrees. So sin r will be equal to 1. So over here k1 should be equal to root 3 divided by 2. So option number A is incorrect. Okay. Now let us see what is happening as the graph proceeds. Okay, we have found out the initial values. Let us see what will happen if the graph proceeds. Now as we go in the right hand side direction, or as we proceed with the graph in the right hand side direction, the value of k goes on increasing. Okay. Now k over here is equal to mu1 divided by mu2, whose value is going on increasing. It is possible in two scenarios. Okay. The first scenario is that, in fact in three scenarios. The first scenario is that the mu1 goes on increasing and the mu2 is constant. That is, this medium, okay, in which the refracted ray occurs, okay, it is becoming denser and denser as compared to that of mu2. Okay. In the second scenario, mu1 remains constant and mu2 goes on decreasing. Okay, that is, the refracted ray, the region in which the refracted ray is entering remains over here, it is constant. Okay, that the refractive index remains constant, but the first ray in which the light is entering, the second medium, okay, is becoming thinner and thinner, so it is become less refractive index. The refractive index is going on decreasing as we proceed with the graph. Okay, in both the scenarios, and in the third scenario, both of them are occurring simultaneously. Okay, in all these three scenarios, understand that the refractive index of the medium in which the refracted rays occurring, okay, or the refracted rays entering, is going on becoming denser as compared to the refractive index mu2. Okay, the region in which the refracted rays entering is becoming denser and denser compared to that of the region 1 at which the light is emerging. Okay, so basically this is happening. Okay, in all these three scenarios, the value of k will be equal to 1. So initially in the first case, when I did not have a refracted ray, the light was entering at an angle I and it is refracted by an angle of refraction 90 degree. So I can clearly see that initially mu1 was a rarer medium and mu2 was a denser medium. How did I infer that? It's very simple. If you see the angle of refraction is greater than the angle of incidence, so I can say that mu1 is a rarer medium and mu2 is a denser medium. But what happens at k2? At k2 you can see that theta is 0. Okay, if theta is 0, I can say that r minus I is equal to 0, that is, I will be equal to r, that is, angle of incidence will be equal to angle of refraction. When the angle of incidence is equal to angle of refraction, I can say that mu1 to 2 is equal to sin I by sin r, which is equal to 1. Okay, since it is equal to sine of angle of incidence is equal to sine of angle of refraction, both of them are same, so both of them will get cancelled out. So at k2 mu1 will be equal to mu2, that is, k2 will be equal to 1. So the option number D is also correct. Okay, let us proceed. Okay, now the medium at which the refracted ray takes place, okay, the refracted ray enters, okay, or the ray enters, okay, after refraction, is becoming denser and denser as compared to the first medium. Okay, so I can say as the medium goes on becoming denser, the refracted ray will start moving towards the normal. Okay, as the refractive index goes on increasing, the ray will start moving towards the normal, and at sufficient refractive index, okay, at very high refractive index, the ray will be very close to the normal. Okay, the ray will be very close to the normal. When the ray gets very close to the normal, the angle of refraction will be equal to 0. Okay, so what is the value of theta 2? Okay, you can see at theta 2, the angle, the line is becoming almost a straight line. Okay, it will not be exactly straight line, but almost a straight line. So angle of refraction becomes 0. So theta, since it is equal to modulus of r minus I, it will be equal to r is equal to 0. So it will be only equal to I, and the I is equal to pi by 3. Okay, so theta 2 will be equal to pi by 3, which is option number C. So the correct answers are B, C and D.